The next speaker here is Brad Green, and he's going to be talking about Angular. I'll let him describe what Angular is, but dominantly there's some interesting facts about Brad. He not only manages our engineering teams in apps and enterprise, but he also has various efforts in Google feedback and accessibility across Google products. The interesting fact about him that he does not prefer to wear shoes, even though we remind him that it's hygienic and otherwise. But he has other data, so maybe afterwards you can reach out to him and understand why he prefers to. But anyway, welcome, Brad, and guide us through your presentation.
Thanks. So how many of you are testing web apps in your jobs? Okay. And how many of you, and you can put your hands down, how many of you develop in JavaScript? Only a couple of us. Okay, so I'd actually like to see many more of us developing in JavaScript. And I'm hoping maybe that's going to change after this talk. I think it's a really cool language. You can totally shoot yourself in the foot. But I'm going to talk about something that's really near and dear to my heart called Angular. And I'll start with a question, which is, what would happen if instead of designing the tools and libraries and frameworks we build, designing them to be hard to test, what if we did the opposite? What if we thought about testing first and made it a first-class citizen? So I'm going to talk a little bit about that in the context of an application framework called Angular. So a little bit about what it is. And sometimes we have a hard time defining what this is to everybody. But it's an application framework, and it tries to promote a standard structure for building web apps. This is unlike some of the great libraries out there like jQuery and Clojure and other ones that provide excellent library functions, but they don't really tell you where to put your code. They don't tell you how to structure the app, and they don't give you conventions for the flow of the application. So in that context, we provide a bunch of application default behavior with the goal of dramatically reducing the complexity of building your web app. So a little bit more about some of the conventions that we've chosen. One of the weird things that we've done, this is very different than most environments, is that instead of having the rendering happen on the server, everything happens in the browser. And I'll show you some examples. We'll see this happening live. And instead of inventing a new templating language, we looked around for what could we possibly use that maybe a lot of people knew, including web designers and developers, that was already understood by tools and editors. And we found this thing called HTML. It's crazy. But we've decided that we could actually get a lot of mileage out of something the browser already understands with some minor modifications. We decided to standardize on a pattern called ModelViewController. Who's heard of this? A couple of us? Okay, who can tell me where ModelViewController started, except for James, who's old? Smalltalk, yes. What company invented Smalltalk? Park Place, but James. So we picked something kind of old, but still good. We'll talk about why that's cool. Something you may not have heard of, we use in the ModelViewController context, we make it even cooler with a pattern called data binding. And who's heard of data binding? A couple of us. Okay, so I'm going to show you an example rather than talk about it too much. So I've got the very basic, simplest Angular app where I've got a text field here and it says world, and down below here you notice it says hello world. Kind of simple, right? So I'll type someone else's names in here like James. You notice as I type, the words update. Whoop-de-doo, right, Brad? Great, great. How much code did I have to write to do this? Well, it turns out none. I'm showing you right now the template that we use, and let me blow this up a little bit for you, in Angular. Where to start off an Angular app, I have to do two things. One, I define an XML namespace, and I import the JavaScript that I'm going to be using. The app, if you could call it an app, does two things. We create this text field where we name it name, brilliant name, and then I have this funny little thing in here that we call markup. We use the syntax of curly braces. And what this says is that I want to bind the name variable to a piece of text here, so that as I type, it updates the name that we have here. We'll talk more about why that's good and what that does for us. But so in most systems that have data binding, what happens is on the server, we'll merge our model of the ModelViewController with a template, and we'll shove it into the view in HTML. Now, you as a developer are then usually left with the task of, if the user changes the view by typing, you have to go update the model. You have to go scroll it away. And if the model changes from some mechanism, like maybe some data comes back from the server, now I have to go update the view. Now, in Angular, we do all that for you. There's nothing for you to do. So what happens in the ModelViewController is you end up specifying the view in some nice declarative HTML. The model is just a set of variables. We'll see that in a minute. And you end up writing just the pieces of business logic that are core to your application, that actually describe what your application does. So we're trying to help you focus on what the app does rather than how to get a browser to do what you want, how to crowbar this funny set of things, web browsers and servers, into your app. So I said all of the app happens in the client, in the web browser. So what do we do with servers? So servers, we still need them, but we need them just to serve the data and to manage our access, to do our security for us. And we've standardized on another pattern called REST. You don't have to use REST, but we make it dead easy. One example of a RESTful data source that already exists is the Google Buzz client. I'll show you another app that we wrote with Angular that uses the Buzz client. These examples are all on the Angular site. You can go to angularjs.org. And what this does is, if I type in the name of some user and click fetch, it'll go out to my set of buzzes and fetch them for me. Like, that's pretty cool. I can expand the replies, see who replied to it, all that good stuff, people's faces, cool. Now, here's the cool thing about this. The whole source for this app is 50 lines. Nobody's saying, whoa? This is whoa! Okay, so let me just walk through a couple things in this. And I won't go into a deep description here, but in the top, we're setting up a declaration of how the RESTful data source is configured. It basically says that when a URL comes back, how do I parse it? And we name this activity. I then create my controller, again, from the ModelViewController paradigm, where I say that I've got a function called fetch, and if fetch happens, I should go ask the activity to get a particular user, and if somebody wants to expand replies, I should say go get the replies. The HTML then is just a user ID, and we default it to Google Buzz, but you could put in my name. We'll go look at that in a minute. A button where I say that when you click it, call the controller's fetch function. And then for the expanding, if I click expand replies, then I should invoke expand replies on the item that I clicked. Okay, back to the slides. Just to make it even a little cooler, one thing that most application frameworks do, and this is one of the kind of key differentiators that lets you know, do I have an application framework versus a library? Frameworks tend to do something called inversion of control or dependency injection. They actually give you all the data you need to perform. This is what I was talking about when I said they show you where your code goes. It gives you a framework for your app to sit in. So you might say, that's awesome, Brad, but what does this have to do with testing? And I think actually all of this has something to do with testing. And I want to talk a little bit about why. So the model view controller paradigm that we have, the HTML view, as we saw, we can actually get a lot of stuff done without writing code. We can do copying data back and forth. We have things that will filter the text that I'm typing, things that will transform it, reformat it as a currency, as a date, or things like that. And so the view, I actually only have to do scenario-based tests or end-to-end tests on. There's no real unit testing to do there. So I've simplified my life already. For testing the controller, though, this is code that I write. We saw the controller for the Buzz client there. I still have to test that. However, because we have dependency injection, it's very loosely coupled. The controller actually doesn't even know about the view because of the bidirectional data binding. It just looks at the data in the model, and if I type something in the view, it automatically updates the model, and I get updated in the controller. The controllers not only have to worry about the view, but they also have to talk to servers. Now, servers and other things that we call services, like the browser itself, we manage, again, through a dependency-injected set of objects that can easily be mocked out. And some examples of these are the browser itself, the Windows document object, exceptions, the location in the browser, logs, a bunch of good stuff. So already, by just using this design principle and coupling it with things like dependency injection and data binding, we've dramatically simplified the amount and reduced the number of tests that you have to write. Let's take a look at how we might mock out a service, just to get down into the code a bit. So in Angular, if I want to create a service, maybe I want to make a really simple one that just pops up a little alert window to the user. That's my service. And I'll define one called notify that returns a function that takes the window object and says, hey, window, pop up the alert message when you get called. And here's the special little magic that allows objects to be injected. We provide a variable or a member called window that tells it I want to have the window object injected by the runtime system for me. So if I were to use this in my application, I could then just call it. I could say, hey, my controller needs to get past a notify object. When I save, I'll call notify and say page save. Now, to inject it, I'll ask my controller to inject notify for me. Now, to test this, however, we can mock it out. We can, for example, create an array to hold results of calling notify, called notifications. We'll create something called a scope. Now, in Angular, a scope is you can think of it as the namespace that controllers operate against. This is the set of variables that are in the model. And what we can do is say, hey, notify, instead of what you normally do, just take whatever text gets passed to you and we'll store it in the notifications variable. So I can then create a controller and call its save method. If we remember from the previous slide, save just calls notify with the text page saved. And in our test, we'll say we want to, and this is some syntax we stole from a behavior-driven framework called Jasmine. And we say we expect that notifications is equal to page saved. It's as simple as that. Okay. Okay. So I'm a little jet lagged. So if I get off course, I want somebody in the audience to shout out what you think I should have said. Let's see. So what's the best kind of test you can write? What is the best kind of test? And maybe I'll describe some characteristics of a best test. It runs infinitely fast. I don't have to maintain it. It never breaks. How would you define this kind of test? What's that? No test. Yeah, it's the test I don't have to write. Now, the way I could not write a test is if I could somehow write less code. And Angular does this for us in a lot of different ways. So we looked at some of the things that it does for us, but we didn't really describe all of it. But if you noticed, in my Buzz client, some of the things I wasn't doing any event handling. The on-click behavior, the controller has no idea that events are happening. Like, it just gets called. This is the bidirectional data binding working for us. Angular handles formatting text for us, updating the view via the data binding. For talking to the server, we have services that know how to parse and marshal JSON objects. This is what was happening with talking to the Buzz client. I didn't write any code to do it. It just happens for me. Escaping strings, there's a bunch of security work we do for you. So less code means less to test. We wrote an app in GWT, Google Web Toolkit. I don't mean to sell against Google's own products, but 17,000 lines of code became 2,000 lines of code in Angular. Man, that's a lot less to test. It's a lot less to maintain. Seems like a good thing to me. Okay, I'm going to show you something that nobody outside of my little office in Mountain View has seen before. Woo! So in addition to our good sort of unit and integration testing story, we also wanted to have a pretty good scenario test story. So we built a scenario test runner. And by the way, this isn't everything you might need. It doesn't simulate browser clicks or drag and drop or any of that. But it does a lot of what a developer needs to do to test code in scenarios. But with intimate knowledge of the way that Angular works, we built a scenario test runner that lets me build really clean and obvious tests. We see some examples below. I'll walk you through some of these. Again, we stole Jasmine's behavior-driven syntax. And one real cool thing that I want to show you is we take the asynchronous nature of browser tests, and for your purposes of writing tests, they look synchronous. Meaning, when I went out to talk to the Buzz client, I said fetch. Now, JavaScript doesn't have threads, so what happened was the browser made a request for me saying, hey, go to the server and get something, and then tell me when you have some data for me. This is a big problem in web app testing. Now, those of you who test web apps probably have seen this, where I will ask my app to perform action X, and then I will somehow have to know when it's okay to verify that it performed action X. So I will wait for a while, or I will go poll until something is available in the UI. And this is really fragile. Like, I might have gotten the thing wrong, or the thing I'm supposed to wait for changes, or the time I wait for it is variable depending on how the service is running. So we wanted to fix that. Let's go take a look at a slightly more complex version of Google Buzz. Now that has some nice CSS, and I think we're at about 100 lines of code for additional functionality, like validation. Oh, hey, I mouse over this, and it says this user is required. So I'll type in my Buzz client. Oh, that's not me. That's me. And so now we get pictures, and we get my enormously chubby baby. We get the ability to expand replies with all kinds of fun animations. We also get this cool filter thing. I can type in pumpkin, oops, or I can type in bees. See all this stuff about bees. Fun stuff, 100 lines of code, pretty snazzy. Okay, but I want to run some tests against this. So I actually built a test runner for this, and I've run them, but I'll just click reload. You can notice it's pausing here, and it's saying this thing, waiting for XHRs to finish. Going a little quick to see, but here's that step. So Angular actually knows when all of its requests to the server have completed, when everybody in the UI has consumed the data and rendered it appropriately and stored it in the model, and the test can continue. If I go look at the code for the test itself, here's my tests. again, we're using this kind of nice, kind of easy to read English-like syntax where I can say, okay, I'm testing the Buzz client. And before each test, I want to navigate to buzz.html. This just loads my client. And I define a test like it should start up empty. And I can write things like, I want to expect that the element identified by this selector is equal to blank. So user ID and the filter, we both want to start up equal to blank. So there's no loading, we're not waiting for anything. But let me scroll down to kind of an interesting test. Here's the one that says, it should expand replies, meaning if I go back here and I see some replies that if I click the replies, it should expand and contract. That's a good thing I want to test. So we actually enter something, we say input, called filter text, enter bees. And then I want to make sure that the element contains 3 replies, great. And then if it does, I'm going to click on it. And then I call this thing called drain XHR, the XML HTTP request. I wait for that to be empty. Now, I think the guys back in the garage have eliminated the need to say this. So in the future, you actually won't have to type anything like that. I then go look for my replies and look for something in Angular called a repeater, maybe just a list of items. And I'm going to say I expect the count to be equal to 3, and I'm going to expect that a particular row has some particular text in it. Now, if you notice, there's not much code written here. This is super easy. This is super easy stuff. It's also going to be super not flaky because I'm not waiting. I don't have to update when maybe the UI changes. I'm not waiting on a particular element. I don't have to guess. There's no selectors to find out what to wait for. We're pretty enthusiastic about this. Okay. All right. So I think that's the main context of my talk. Although I did want to send out a big shout out to another tool that we use to build Angular, which is called jstestdriver. It's our test runner for small tests, medium tests, and we're actually running the scenario tests in it as well. It runs tests on every save. It's got integration support for Eclipse and IntelliJ. Runs hundreds or maybe even thousands of tests in under a second, depending on your browser. It runs in parallel across multiple browsers. It gives you the ability to declaratively specify the HTML dependencies you have for a test. Matter of fact, there's even a book somebody wrote, doesn't even work for Google. I don't know this guy. I think Corey knows him. On how to do test-driven development using jstestdriver. Pick it up. It's good stuff. Got references for the talk, including the slides. I've got a nice short URL if you want to go review them tonight in your hotel. I know you will. Couple questions before we move on to the next speaker. Maybe one from Bangalore to start with. Okay, how about one from Hyderabad? Go ahead.
Hi, I'm Bharat here from National Instruments. I understood that this Angular supports JavaScript, but I want to know whether you support other platforms like, especially Silverlight web applications, or.
So no. So this is an environment written in JavaScript. You can only write the code in JavaScript. You could port it to Silverlight, I would think. It's an open source platform, so that would be interesting. I'd be interested to see what you could come up with.
Oh yeah. Thanks a lot. Yeah.
Sure. Maybe a question here. Can we pass the microphone to the man in the green shirt? Yeah, go ahead and speak, and I'll repeat your question. Yeah. So the question was, using Angular, can I determine when an XHR is completed and when the response has reached the browser and is completed? Yes. So the question was, how do we do that? And we wrap the XHR object in our own Angular object that monitors its completeness. Let me and I know I said I was going to talk about this, and I totally forgot. This is where you guys were supposed to stop me and ask me something. How does this test do what it does? And let me call it out a little. If you notice, drain XHR actually it actually waits. And there's no threads in JavaScript, and so I can't be polling. Normally this should just continue. So this is similar magic to what we do for waiting for the XHRs. But what's actually happening is this test does not run the test. What happens is when I call input, it puts a request on a stack. And then when I call element, it puts a second request on a stack. Drain XHR is another request on a stack. And so what we do is we roll through the stack in our test. And the XHR that we're waiting for, the way we know it's completed is we get a callback that tells us it's complete. And then we can move to the next step. So in the same way we move to the next step in each piece of our test, that's how the application framework knows that everything is loaded. And I can tell, for example, I can tell the data binding to go populate the UI or anyone else that wants to consume the data that came back from the server. Say it louder for me. It's still not a synchronous request, but we've made the programming simpler with some syntactic sugar, so that you don't have to think about callbacks and handling that in the test itself. Behind the scenes, that's all callbacks with closures.
Okay, thank you so much.
Yeah. And do we have another question in Bangalore, or should we go to one? Raise your hand if you have one in Bangalore. Okay, let's go here to the man with the microphone.
This is Varun. I would like to know how old is this framework?
How old is the framework? It's been in development for about 2 years, although we're still feeling like there's a lot we want to do, but yeah, it's been around for quite a while.
And so, what are all the Google products which are currently using this framework?
So we don't have external Google products using it currently. We have some internal ones, and several other folks in the open source community are using it.
Okay. Okay. Thanks.
All right. Do I have another question, or should we move to the next speaker? Yeah, one in here in front. Do you want to bring the mic up? Okay, I'll now go ahead. Take the mic if you would, please.
Yeah. In which area of internal development are you using this Angular language?
Okay. So was the question? What kind of apps is this good for building?
Exactly. Yes.
Yeah. Okay. So this is good for building things that don't require a rich editing surface. Meaning, if I was building a spreadsheet or a word processor, I might not use Angular for that part. I might use it, however, to build the menu system and everything that holds that component. So it's great for CRUD apps. It's great for things like if I was building an expense reporting tool, if I was building a general workflow HR apps. Like I could see building Gmail, Calendar, like several of Google's kind of rich UI products in it. But for things that have custom UI editing, I would build those using some lower level libraries.
Okay, thank you.
Yeah, good question. Thanks everybody.